Welcome to Tactic Academy, where we'll be looking at CH110 paper 2023 deferred. Alright, so in this video we'll answer the whole paper. Make sure that you understand the video, pause where not clear, and try to understand by all means. So without even wasting our time, shall we get started? So the first question is introduction to chemistry always. So we are here now to answer all the questions under introduction to chemistry, right? So the first question says, state the 5 steps involved in scientific notation. So as a scientist, you need to actually, let's say you want to come up with a theory, or how you start, or how you start. Scientists always do the following. They will see a problem. Let's say, all members are tails lie. Okay, what theory can I use? Let's say I'll use Socrates theory. You phrase from a certain theory. After you just come up with an imagination, then phrase a theory that will actually try to imitate the behavior, the new behavior that you have, because you can't just start without a reference. So you start like that. So the first important thing that you need to do as a scientist so I'll try and at least 5 all of them. Okay, so I'll say the first step is to carefully define the problem. Let's say Bemba's tells lie. So you carefully define the problem. So I'll define the problem to say, student don't study, or student clear their courses. Okay, that's just a problem. So I'll define that. So you say careful definition of the problem. So you define a problem. So I'll say careful definition of a problem. That's what I said. All right, so as a scientist, you need to do what? To define the problem that you are about to study, okay, or to conduct an experiment on. Okay, so you define a problem like that. Okay, then the second thing that you need to do is to actually perform an experiment now. Performing an experiment now. All right, an experiment. Okay, after performing an experiment, what do? You interpret the experiment data. So as a scientist, after just you conduct an experiment, so it happens like you observe the problem, then you define the problem, and get a reference, then perform an experiment. From an experiment, extract that data. We're saying now interpretation of what? Of the data. So we'll say interpretation of the, let me say, experimental data. All right, so I'll say experimental data or results. Let me say results. So you now interpret the data that you have, all right, after just doing an experiment. So the fourth one will be, since you have now interpreted the data, let's say it's correct, so you summarize that data into concisive statement, and that's what we call a law. Okay, a concisive statement. So summarizing the data, summarizing the data into a concise statement. All right, so for this one, you can there are 2 things to do here. You can so when it has repeatedly been experimented, that will be now what we call a law. If it is just a you have just started it, then it need to be what? it need to be a theory, just because you have just done it and it's not proven, let's say, wildly. Okay, so that will be now, let's say, a concisive statement which is called a law, or which is a law. All right, So a law will be accepted. It can't be changed. Let's say a law of what? A law of universe. Those are laws whereby you can't change them. Then the second one, the fifth one will say, after you have done this, you write the concisive statement, which is just a law. Now the fifth one, the fifth point will be generation of the hypothesis or a theory. Just so we generate a theory. All right. So a theory now is the one now that you have just come up with. All right, that's your only proven experiment, so you call it a theory of what? Big Bang theory. That was just for one person, so generation of theory. All right, so from that proven hypothesis, so hypothesis is just that statement you make the moment you see the problem. That's hypothesis. Oh, this is shan. That the statement before judgment is called hypothesis. All right. So from that hypothesis, all right, you generate a theory. So that is it. That's about scientific steps. All right. So you just have to master these. All right. Let's go. So distinguish between extensive and intensive property of matter. So when we say extensive property, all right, so for extensive so for intensive first, intensive, so for this one you consider a matter in terms of not really the amount, but something that depends not on the amount. That is intensive. All right, but for extensive for extensive, it depends. This property depends on how much matter you have or how much matter is available. Let's say 2 kg. All right, so you consider matter. This one is what? This one is so in short, mass, such as mass, those are volume. All right, those are extensive. You consider them as, oh, it has this volume, it has this volume. So this one, let's say these are 2 stones. All right, this one, it has 2 kg, this one has 4 kg. So you are differentiating these two guys from just based on the amount they have. But for intensive, it's a situation whereby you don't consider the properties or the amount of matter variable. So you say, let's say temperature. All right, so temperature is one way whereby you can't say, oh, this bottle has this temperature. Let's say this is all mercury. All right, mercury will melt, let's say, at a temperature of 25 degrees Celsius. So every mercury, even if it be small or big, it will all melt at 25 degrees Celsius. All right, so that's what we mean when we say extensive. So we can say, to distinguish these two, we can say extensive property depends on how much matter is being considered, but for intensive, we'll say now it does not depend on how much matter you have. So this one just depends on the property, just. All right, property itself, like let's say we can say chemical properties to say. So that is it. Let's go to the next question. Perform the following mathematical operation and express each result to correct number of significant figures. So what you can do, let me just I'll explain as I'll be solving this one. So we are saying question 1 like that. So we have 0.1654 plus 2.07 minus 2.114. Right, so for us to solve this one, or to evaluate this one, we are going to say, please, when you are reporting these answers, you at least present the answer to the least number in that operation you had. All right, so what we are going to do here is for a negative one, this one I'll add these two, which are just having the addition part. All right, so once I add them, the least number that I can have between these two and this one is the 2 decimal places, which is there. So what I'll do, I'll report my answer. So when you add these two, they'll give you what? 2.114. 2.24. All right, I'll report the answer in the form of this one because that's the list I had. All right. Okay, so once I subtract this one, then it will give me what? It will give me the list now again is having this, despite me having these three significant figures, decimal places, I mean, I'll report my answer to 2 decimal places. That is, now when I subtract that, it will give me 0.13 like that. So that is correct to the number of significant figures 2. All right, you report 2 or just 2 decimal places. All right, so for the second one, you say you say you report now 827 like that, open bracket, 4.987 minus 4.962 like that. All right, so what you do is you do what is brackets of we didn't body mass, so we deal with what is in the bracket first. So say 8.27 like that, open bracket. When you subtract there inside, it will give you 0.025 like that. Then that will give us what? You multiply. Now the list is having what? 2 decimal places. So just for the multiplication, division, addition, or subtraction, they're just the same. You consider the least number of decimal places. All right, so now the least number is 2. Here we had 3, but here is 2, so we report our answer into 2. So when you multiply that, that will give you 0.21, correct to what? Significant number. All right, so that is it. So you can copy these and also write it in your book. They'll be very important. So this is correct to 2 significant figures. All right, so the other thing that we can do, show your understanding metric prefix by giving the name of each of the following unit equal to the following unit. So we learned about in unit and measurements. I posted the video, I'm sure. So that one will be 10 to the power 12, that is called Taylor. So we just represent to say this is the Taylor, that value is Taylor, then there's gram there. All right, so Taylor gram. So number 2, the value there for 10 to the power -9, that will give you what? Nano. So that will be nanometer. So you just put the answer for all right, you just put the answer for nanometer, a meter there. All right, you just put the answer for the factor that you have there. Then the third one, 15 to 10 to the power -15, that is called femto. All right, so it's called femto. All right, so femto, then femtometer, it will be femtometer because we had the meter there. So the factor is femto, the factor is nano, the factor is Taylor. All right, so that's how you are supposed to answer that question. You are supposed to answer like that. All right, so next page. All right, a compound containing 40% carbon and 6.67% hydrogen, the molecular mass of the compound is 60.0 grams per mole. For this compound, determine the empirical formula. All right, this is interesting. So what we are going to do, this is actually what we call combustion analysis. So what we do is we have different things here. All right, so what you do is, for us to determine get the way atoms or elements have been mentioned. So I'll say carbon, I have hydrogen there. All right, is there another one? No. Yes, I must have there's someone again here. So a compound containing 40% carbon, 6.67 hydrogen, the molecular mass of compound is this one. So for this compound, determine so there was another guy that we can't just see there. All right, there was another guy that we can't just see because the percent, let's add this percent, it means there was another guy. You always take a guy called oxygen. That's how these guys move. So you say you had now 40% plus, or just 40% plus 6.67%. all right, these can't give you 100%. We always want 100%. So what you do is you say 100% minus, open bracket, this what is available, then it will give you, so we'll say 40 plus 6.67, all right, then is equal to x that we don't know. All right, so that will be 100 minus this will give us what? It will give us what? When you do that, everything there in the on your calculator, that will be all right. So you punch 6.67 like that is equals to x. So when you punch like that, it will give you what x is equals to 53. All right, 53.3. all right, so that is it, percent. So that's the percent for what, for oxygen. So now what we do is we bring those percentage. So for this guy had 40, for hydrogen had 6.67. all right, for this guy now is 53.3 like that. So what you do now, you divide the throughout by their molar mass. all right, so after dividing the throughout by their molar mass, so for this guy is 0. On your periodic table, on the periodic table, you find that carbon has 2. Then for hydrogen is 1.01 like that. Then for oxygen is 16.00, just to say. Then you divide. After dividing those, now you are getting what? This here you get 3.3 like that. Okay. Then here it will give you, and divide. Let me just punch on my calculator. So that will give me 6.60. all right. Then this one to give me 3.33 again. So here what we do is what we do here is you always what, you only round off when a number is 8 to 9 like that. The rest you can do what, you can find means of multiplying a factor, a common factor that will increase the numbers. We'll do that, maybe we'll meet a question. all right. So what you do is now you divide throughout by 3, because that's the list. So you divide throughout by the list number that you have. In this case we have 3.33. This will divide throughout. all right, so we'll say 3.33, 3.33, 3.33. all right, so that is it. So I said 3.33 like that. So here it will give you 1 point, just 1. Yes, it's 1. all right. Here it will give you now 1.98. wow, we have even, and also blah blah blah. I'll just get these two. Then here I'll have 1 when you divide that. So meaning that I said when you have 8 to 9 like that, these ones can round off under this. The rest can just do what, can just multiply. You look for a number, a factor that will increase the number to those, to reach these point numbers. all right, so here it will be 1. Here you round off, that will be 2. Then here it will be 1 like that. So therefore the molecular formula of this empirical formula of this guy compound, it will be CH, all right, oxygen like that. So C has 1, hydrogen has 2 there, then 1 like that. So this is the what we call now the empirical formula. all right, empirical formula like that. all right, so we are done here. So this is the empirical formula of this compound. okay, so what about the molecular formula? Now we have now seen how to calculate the empirical formula. What about just the molecular formula? all right, so a molecular formula is the formula that shows the actual number of atoms in a molecule or a compound. all right, so there might be other numbers which were used to multiply this, but you now want to get the actual number. So that's what we call empirical formula. all right, so for empirical formula, what you do is you say empirical formula. So empirical formula, by the way, before I even say empirical formula, I'll say for a molecular formula, all right, is equal to empirical formula, all right, times the number factor n. Now how do we get this n? So we have already, so the n will be gotten by saying actual, there is actual mass given in the formula over theoretical of an empirical formula. So theoretical calculation of empirical formula. all right, so what we do is theoretical calculation of empirical formula now will be you get this compound that you have here. all right, so you get to say CH2O like that. So you say you get the molecular formula from this empirical. So this will be 12.01. this will be just now 2.02. This will be now 16, which is just 16.00, like that. So you add these now, they will give you what? Once you add these guys, they will give you 30. They give you what? 30.03. So 30.03, like that. So this is the what? This is the molecular theoretically. So that's what we got from this empirical formula. So that's the what? The mass. So what we get now to find the N, we'll say the actual mass which was given now 60, divide by what? Divide by the theoretical yield mass. So that is now theoretically empirical formula. This is the one we are from just getting 23, like that. So when you divide like that, that will give us what? That will give us 1.99, like that. So I said for 9, 8 and 9 you round off, so this will be just 2. All right, so we have found the one, I mean the N that we were looking. All right, so very easy. So since now we know that our N now is 2, what we do is we continue saying molecular formula is equal to empirical formula. All right, empirical formula multiplied by this N. The N is now 2. Our empirical formula is CH2, all right, or like that. So you multiply times 2, like that. So the final answer will be C2H4 or 2 when you distribute these 2 there. All right, so that will give you what? That will give you the molecular formula. So this is the molecular formula that we needed to calculate. All right, so by this we can see now that these were actual numbers of atoms, all right, in this molecule, meaning that the rest for empirical formula it was just simplified. Oh, that's the meaning there. All right, so let's go to the next question. Okay, so that is question 2. And that's your chemistry. So what we do here is we have been given a question to say in an experiment to make a crystal of hydrated copper 2 sulfur-nitrate, a sample of 5.60 grams of copper 2 oxide was added to 7.878 grams nitric acid. Calculate the number of moles of each reactant present and use this to show that the copper 2 oxide was in excess. In short, we are trying to find the limiting reagent and see which one is the limiting, then we'll be able to tell the other one to say it's excess. So how do we get that? Let me teach you the easy trick on how to do that. So the first thing that so in an experiment to make crystal of hydrated copper sulfate, a sample of 5 grams copper oxide. So now we are reacting copper 2 oxide, so we are saying now copper. Okay, so when you say copper 2, meaning it has a valence of 2, so meaning plus oxygen, the oxygen that it will react, those 2 will cancel, right? This is 2 and also has 2, so we just write copper oxide like that, copper dioxide or copper just oxide. Then this is a solid if you were to imagine. Then we are writing now nitric acid which was there, which was added. So we have nitric acid there, that is now nitric acid there, the formula is there. Then it is in aqueous, this one I guess. So then you light this is just a displacement reaction. Then you light your reaction like that, it will displace, the copper will displace the hydrogen there. Then that is 2. Ammonia has the valence of what? Nitrate has the valence of -1, so it will just come there 1. We know how to write the equation. Let me not take it. So this was acid plus the base. So copper hydroxide is a base to say. So we'll form water there, H2O. All right. So which is the liquid. Okay. So now from here we'll be able now to calculate. Let's calculate the moles of each of these guys. So we have the data of the mass of this guy and this. First, let's calculate the limiting reagent. How do we calculate the limiting reagent? All right. So we'll calculate the limiting reagent by saying we have copper, so we bring their masses there. So we bring, for copper we have 5 7.60 grams. All right. For nitrate we have 7.878, all right, like that. So you divide throughout by their molar mass. So the molar mass, when you get the molar mass from this guy, you know how to get the molar mass. You get those masses, you multiply by, like for oxygen, you multiply times 3 of that on the periodic table. So you get that, and then you say you divide throughout by their molar. So when you find the molar mass, I can't do that, I've already say I know the molar mass already. So you say copper oxide, it is what? It has the mass of, when you calculate, that is 79.45. So that is 79.45. all right. For now nitric acid, the molar mass is 63.0125. So 63.0125, like that. So meaning that the moles of this copper sulfate, copper hydroxide, copper oxide is now 0.07 moles. All right. Then for nitric acid, when you divide that, your mole now will be what? 0. By the way, these were grams. The masses that you were given, they were grams, so these were in grams per mole. All right, grams per mole. That's why we are on the periodic table, those masses are measured in grams per mole, so that's why we have written, and these grams will cancel, if you can see. All right, you remain with the moles. So for this one, for nitric acid, now it will give you what? When you divide that to be 25, like that, moles. All right. So this is now the trick that you do. By the way, this equation wasn't balanced. I can see nitric acid there having what? 2. So what I'll do is I'll multiply here by 2. And for hydrogen, it has also balanced. You have seen we have 2 there. Everything now, the equation is balanced. So once the equation is balanced, that's how you proceed now this stage, or just in the first step. So from here now you divide by their coefficient. This is the trick that I'm teaching you to find the this. After you find just the moles, divide by these guys, these coefficient which are there. All right. Okay, so you divide throughout. So we'll divide throughout. So here we divide by 2 because this is the 2 we have there. Then here we have only 1 there, so we divide by 1. So this will give us 0.07. Here it will give us what? 0.0625, like that. All right. So these are the moles required in this reaction, and also these are the moles required. So after you do this, meaning that this is the easy way of finding limiting agent. We can see which one is small between these two numbers. Let's say A or B. All right. We can see that A is bigger, so B is what? Smaller. So therefore B is the limiting agent. Now to answer the question which says copper was in excess, so really copper was in excess, we can see there. All right. So copper was in excess, like that. So you end there. Easy stuff. All right. So that means that copper was in excess. All right. So now we are here now to calculate or to solve all right. So question 2 says the copper to nitrate solution was heated gently to concentrate it and then lift it to crystallize. So it means the copper was left to dry so that they can collect those precipitate. Then the mass of hydrated copper to nitrate crystal obtained was 5.52. So here there was an error in the question. This was supposed to be 12.52, like that. All right. Calculate the percentage yield. So to calculate the percentage yield is equal to actual, all right, over theoretical, all right, times 100, like that, percent. All right. It will be expressed in the form of percent. So how do we do it? So you bring now what is involved in now the limiting agent is what? Is this nitric acid. So we'll present nitric acid plus this copper hydrated nitrate. So what we do is we bring them into their simplest ratio. All right. So you say you say you get the molecule that was in limiting reagent, because the one which limited the product to be formed. So I'll say that is 2 nitrate like that, or 3 like that, then dot. I'll put them into that simplest ratio. All right. Okay, so now we have the limiting reagent, the moles of this guy. All right, so I'll bring now their moles. So what I'll do first, I'll put the mole ratios. Here is 2, there is 1, right? Meaning that, okay, so those are the what? Okay, so those are the mole ratios. So what I'm going to do is now I'm going to say, let me find the moles. Since I have the moles of ammonia from the previous question, I calculated the moles of nitric acid, and that was, if you can remember, let me think about it. That was 0.25. All right, that was 25 before we found the limiting reagent. So that was 0.125. All right. So this was the mole of that guy available in the reaction. So now I'll bring it here. So I'll say 0.125 x there. So you divide like that. So we're trying to find the moles of copper nitrate. All right. So when you multiply there, so that will be 2x is equal to 0.125 like that. So you divide throughout by 2. So our x now will be what? 0.625 like that moles. All right, so these are the moles needed to do what? So now from these moles we'll be able now to find, we know how to find the moles. So it's equals to molar mass like that. So number of moles is equals to the mass given there in grams, then over molar mass measured in grams per mole. So I'll say to find now the mass is I'm going to say, because I need to find the mass, I've already been given the what, the actual mass, to say it's 12.52 there. All right, so meaning that what I'll do is I'll say now this mole, there's 1 there, so you cross multiply, so that will be mole times molar mass of that. So we have the number of moles now for copper nitrate, that is 0.625. all right, moles times now the molar mass. What is the molar mass of copper nitrate? So the molar mass of copper nitrate is what? We can just calculate. It is you calculate the copper. So you say copper nitrate, all right, to there. So you do this, you calculate the molar mass. That's how we calculate the molar mass. You know what I'm talking about. Then that will give us what? That will give us 295.6 like that. All right, that is grams per mole. All right, so the mole will go, then the grams now will remain. So the mass is now, this m should be in small letter, by the way. This is now 18.457. so this is 18.475 like that. All right, so grams. So this is the mass now that we have. All right, so since we have this mass, okay, since we have this mass now, what we are going to do is we say percentage yield, okay, is equal to actual, which is given now is 12 point, it's here guys, 12.52. all right, was then calculate the percentage. So 12.52. I said they made a mistake. So you divide now with what you have. This is now 18.475 like that, then times 100 like that. So that will give you what? 0.67 like that, 767 like that. So meaning that times 100, now you multiply times 100 that number, so that will give you 67% 0.7 like that, which is just 68%. All right, so this is the percentage yield that we are supposed to calculate. So that is it about this question. All right, so organic compound Y contains carbon, hydrogen, oxygen, and nitrogen. A 0.132 of compound Y is bound completely in oxygen to produce 0.072 grams of oxygen of water, 0.176 grams of carbon dioxide, and 0.028 grams of nitrogen. The molar mass of Y is 132 grams per mole. Deduce the molecular formula. All right, wow, this is good. So we are now deducing the molecular formula for Y. So this is combustion analysis. You need to have logic here, because one thing is not given. All right, so we have been given so get the question. Compound Y contain carbon, hydrogen, oxygen. So there's carbon, hydrogen, oxygen. So we are saying there's carbon, all right, hydrogen, and oxygen. Okay, so even nitrogen, there's also nitrogen. All right, the way they have been mentioned, you bring them there like that. Then we are saying now for carbon dioxide, for nitrogen, let's get, because we are calculating the, it's more like the empirical formula. That's the first step. So for nitrogen, you'll be given the mass to say 0.5 and the nitrogen 0 point something. All right, so let's get now their masses so that we calculate the empirical formula from calculating the empirical formula in the previous video, in the previous question. So we are now also to calculate the same thing. All right, so what we are going to do is we are going to say, okay, a organic compound Y contain carbon, hydrogen, oxygen, and nitrogen. So a 0.132 of Y, which is compound Y, is produced to produce 0 point so H2O there, 0 point, and also there is carbon dioxide. All right, okay, so that is it. Then there's also nitrogen we have there. So for nitrogen, we are saying the given mass is 0.028 grams. Then for oxygen, we can even write it here, 0.028 grams. Then for oxygen, we don't have. For carbon, we need to have hydrogen independent, carbon independent, and oxygen independent, like that. That's when we can press them. So now that in H2O we have what? We have 0.07, so say 0.072 like that grams. So in this one we have, meaning that in this H2O that we have here, we can see oxygen is 1, hydrogen is 2. So what we are going to do is, these guys are the masses, all right, in this total that we have there. All right, so they have the ratio. For oxygen, for hydrogen is 2. All right, so what you do is you bring, so to find the number of oxygen, it's more like we have 10 suites. All right, we have 10 houses. All right, we have 10 houses. You and I, we have 10 houses. Then me, I used what, 8 pin, all right, to build, or just 8 kwacha to buy those 10, and then you use 2 kwacha, so we are making 10, all of that. So the ratio is you who got 2, you put that 2 over the total that we have is 10 times those 10 houses. All right, so this and this will cancel, so you get 2 houses because you just gave 2 kwacha. For me now, who has 8, I'll say 1 over 10 like that times 10. So we'll cancel this 10, will give us 8. So I've used 8 in short. So my contribution ratio is higher than yours. So that's what we are going to do here. So this is the scenario as well. All right. So for oxygen and hydrogen, so in the H2O, like that, hydrogen had what? Let's get the mass of hydrogen. Hydrogen has what? 1.01 over the total now of this H2O is having what? The total mass of H2O is 18.02, like that. So this guy had 2, the contribution. So meaning it has 2 like that, yes. So what we do is we multiply that 2 again times the available houses that we have. All right, because he had 2, so we'll put him as what? All right, I'll just put direct. This will be now when you multiply times 2, that will give us 2.2 like that. All right, so allow me just to lab. Okay, so what we do is we are saying this guy had 2, so we get the molar mass of hydrogen. That will be 1.02 times 2, this which is there. All right, that will be now 2.01 or 02 years over the total of this guy. The total is now 18.01. all right, 18.02. Yeah, it's 02. Then times what you have now, we have 0.072 like that. So that will give us for hydrogen, because we have put the ratio of hydrogen on top there in this contribution. So we are saying now hydrogen is equals to, when you multiply that, that will give you what? That will give you 0.008 like that grams. So that was it. That this is the mass of what? Hydrogen. So we'll put there as the hydrogen. All right, grams. So we have remained with oxygen. So for oxygen, we can also, for oxygen is difficult because it's found in what? In these two, in carbon dioxide and what? In in also H2O. So what we are going to do is we'll get that for carbon, since carbon is not found in that, we'll also get from carbon as well. All right, okay, so we have ticked hydrogen. So what we do is now we'll calculate the number of what? For carbon in the carbon dioxide. So in the carbon dioxide, we have carbon there, so carbon is contributing 1, so we just bring the mass of what? Of carbon, which is just 12.01 over the total. Now with this carbon dioxide, the mass is what? Is 44, the molecular mass. All right, so that is 44.01 like that. Then you multiply times that variable number for carbon dioxide. Carbon dioxide we had what? Carbon dioxide we had this 0.176 like that, which is this one. All right, so what we do is now you multiply times that number, so 0.176. so that is for carbon. All right, so that will give you what? When you multiply that, it will give you 0.04, so 0.048 grams. All right, so for carbon is now 0.048 gram. All right, so we have remained with oxygen. Now how do we calculate for oxygen? This is where now it is bit trick. All right, all right, so what we do is to calculate the one for oxygen, you say that oxygen we have is equal to the total minus open bracket, this is just the list. All right, so we have hydrogen plus oxygen. No, we are calculating for oxygen, so I'll say plus nitrogen plus carbon like that. So we bring their masses. So our y had what? 0.13 there. All right, so that is 0.132 minus open bracket. For hydrogen is what? Is 0.008 plus, all right, plus, right, plus for nitrogen is what? Nitrogen is 0.28 gram. Then plus for carbon is now 0.048 like that. All right, so when you punch on your calculator, you find that for oxygen it will give you what? It will give you 0.048 again, right, gram. So that's how you calculate for oxygen. Okay, so very important trick question. Okay, so very important trick question. It's important that you do what is needed here. So that is it. So now that we have these guys now with their masses, how do we calculate them? We start with the empirical formula, then molecular formula. We all know that, right? So we divide now throughout by the what? By their molar mass, all right, on the periodic table. All right. So the molar mass now, the molar mass of carbon is now what? 12.01. This one is 1.01. This one is 16 point. Alright. This one is 16.00 like that. Then this one is for nitrogen is 14.01 like that. So you divide throughout these numbers. So that will give you what? Here it will give you 0.0039. Let me just end there. Then here it will give you 0.0079. Here it will give you 0.005. Here it will give you 0.00 when you divide 19. I'll be just leaving it like this. Then from there now you do what? You multiply, you divide throughout by the list number. Alright, so the list number is what? When you check here, what is the list number? Okay, what is the list number? Okay, so what I'll do is I'll do this in the next step. I'll be just leaving to the 3 decimal places. So this will be 0.00. I'll put 4 there. All right, this should match. So this one will be 0.008 there, right? This will be just okay, 0.05 like that. Then this will be 0.002 like that, right? Okay, is that okay? So what I'll do is now these things are now matching. So what I'll do is I can multiply. Okay, just I multiply by 1000 so that I multiply times 1000. No, just get, they are just the same. This is the lowest they can. So 0.0, the comparison is now on the 3 decimal place. So when let me just multiply it by 1000 so that I can bring this. When I multiply, that will be 4, that will be 8, that will be 5, that will be 2 like that. You get the point. So there's no difference here. All right, this is the for oxygen is 3 there. When you divide, is 3 there. All right. Okay, that is 3. All right, I didn't make the mistake. So from here now you can say, oh, now this is the empirical formula. Now you get them H like that or N like that. So here for hydrogen, for nitrogen is now 2, for oxygen is 3, for hydrogen is 8, for carbon is 4 like that. So this is what we call now the empirical formula. So this is the empirical formula. All right, so we know how to get the what. So since we have the empirical formula, can we calculate the the molecular formula now? So what we do is molecular formula is equal to empirical formula times the N. Okay, this factor N. So N is now equal to theoretical or actual yield over theoretically. All right, theoretical yield times 100 like that percent. Okay, so the actual here that we were given is what? We were given what? They are saying the molar mass of Y is now 132. So say 132 grams per mole. All right, over theoretical. So the mass that we calculate from this now theoretically from this empirical. So what you do is now you get the same empirical, you calculate the molar mass like that. All right, so that molar mass that you get, that will be what? When you calculate that, that will give you still 132. I've already calculated, so you calculate that will give you 132 like that. All right, that's the molar mass of this guy. Okay, so now meaning that from the periodic table, so you bring now again 132 like that, or grams like that. Okay, so the grams will cancel, the mole will cancel as well. So the n now is what? Is 1. Okay, so in this case the molecular formula is equal to empirical formula. All right, so molecular formula now is equal to empirical formula, which is C4 hydrogen 8 oxygen 3 nitrogen 2 like that. So this was the answer. Thank you very much. Let's go for understanding. Let's go to the next page as well. All right, so complete, that is now reaction in aqueous. Complete the following reaction and identify the precipitate formed. If there is no, please specify. Okay, so what you are going to do, let me just complete the reactions. All right, so this here, it will be it's more like a displacement reaction. So I'll say this is the ion will go with hydroxide there, so that will be what? That will be ion that was ion 3 hydroxide. So put the hydroxide inside the ion 3 here, then plus, so this is a solid, by the way, that is a solid, then plus the hydroxide. Now the sodium will go with nitrate, so it will be now sodium nitrate like that. All right, okay, so this is aqueous. All right, so what you do is, that's an aqueous thing. So by, okay, let me just complete also this one. So that will be now barium sulfate. So that will be now, let me start with aluminium chloride. So that is when I get that. So when you write the reaction properly, so that is aluminium chloride like that, then plus barium sulfate like that. Okay, barium sulfate like that. Okay, so by balancing the reaction, we can see here sulfate has 3, so we'll put 3 there. All right, we'll put 3 there. Then the aluminium there had 2, so we'll put 2 there. Okay, then from there we can see that the solid barium sulfate is always a solid. Do you know this salt? Then for this one, we are saying now, let me just write it here. So okay, so let me just complete the reaction. What I'll do is also is some kind of displacement reaction. So the hydrogen now will go on the acid, then this one will go with the, so we'll have hydrogen with nitrate, that will give us nitric acid. Then the zinc will go with ion. All right, with iodine there. So meaning that this is the thing formed. All right, so this is aqueous, this is also aqueous. Have you seen, this is iodine. Iodine is from group what? You see that it's an aqueous thing. This is not a solid. All right, so there's no solid. Since there's no solid, so for this one the solid is there, so meaning PPT is formed. All right, and the PPT is the same solid. Also here is a barium sulfate, so the PPT formed is barium sulfate. Then here we have this guy is an aqueous, so there's no PPT here. All right, sure, you can conduct an experiment for this. So that is it about this one. Okay, let's go to the next question. Sodium sulfate react with barium hydroxide. For this reaction, write the molecular equation. So we are here now to write the molecular equation. All right, the molecular equation. So we are going to say sodium sulfate. So say, all right, sodium sulfate like that to there. All right, sodium sulfate plus react with barium hydroxide. So we'll say barium hydroxide like that. All right, okay, then giving us what? It's a displacement, by the way, sodium hydroxide. All right, so the sodium will go on the hydroxide, so double displacement reaction. Okay, plus barium sulfate like that. Okay, the barium is having a valence of 2, sulfate 2, so it has balanced like that. Okay, so from here now, what we are going to do is, let's just balance this. So we are now going to light, so this is the molecular reaction or equation. Then number 2 is we are going to light what the ionic. In ionic you just separate these guys, all right? So what we are going to do is, here we had 2, so we say 2 sodium plus, by the way, plus sulfate, by the way, they are in aqueous, these guys, all right? Then this is a solid barium sulfate, we are from talking about it. Then what we are going to do is we light here sulfate, all right, with a negative there. Okay, then plus again the barium with a plus there, then plus hydroxide, you put a 2 there, that 2 which has just to balance it, all right, a negative there, then equal to what, sodium plus hydroxide, all right, all right, just to balance. So you write 2 because you have 2 hydroxide there, then you have also 2 sodium there. That is when you balance the reaction. Okay, so that is when you balance the reaction. So here there was supposed to be 2 there. Okay, so that is the balanced reaction. Then plus barium sulfate will remain like that, all right. So this is a solid. So we can see now, that we are done with it. That is how to write the ionic equation. The net, now you are trying to cancel all the spectators, those things that are just there to escort. In short, things that are found on both sides, like we can talk of sodium there, we can talk of sodium there has gone, sulfate there, no sulfate can't go, all right. So we have barium there also, but so there is hydroxide there and also hydroxide there. So we are, the net one will be sulfate, all right, sulfate like that. Okay, then plus barium there, barium with a plus there, then equal to or giving us what, barium sulfate like that, all right. So this is balance equation, and we have this is a net ionic equation. In short, this is how to write the net ionic equation. Thank you very much for understanding this one. So let's go. So calculate the oxidation state of the underlined element below, all right. So how do we calculate the element underlined below? So for chromium here, what we do is you write chromium like that, open bracket H2, all right, or close 6 with a charge of what, positive 3 like that. So how do we calculate this guy? So let me present it to say X, to mean X, that's Cr, all right. So what I'm going to do is I'll say that is X, okay, plus now, plus I'll just come here, all right. The charge of water is what? The charge of water. What is the charge of water? What is its charge, please? So water is charged to 0 in just its natural, in this case of reacting with a metal. So it has a charge of what? 0 in its normal. So when you just find H2O like that, it has a charge of 0. So you say this 6 times that. So you say 6 times that is 0. You equate it to the charge given. So the charge given there is C positive 3 like that. So what you do is you say X is equal to, that is already 0, so is equal to positive 3. You are done. Okay, so that is for question number 1. For question number 2, we are saying now we are finding now for what? There's potassium there, magnesium, manganese, then O4 like that. So we are calculating for this guy. So for potassium in this state, it is in group 1, so it has an oxidation state of 1, all right, positive 1 to say. Then plus this guy, let me present it X. Then we have oxygen there, right? We have oxygen there, oxygen with a 2 there. There is a valence of 2 in its oxygen has a in group 6. It has the, what's this, the valence number of 2. So I'll say plus open bracket 4 times negative 2, like that. So this 4 you multiply times the charge for oxygen. All right, so you equate, the compound is equated to 0, there's nothing there. All right, so it's 0. All right, so now you say x negative 8 plus 1 is equals to 0, which is just the x is equals to positive 7, like that. All right, so meaning that this is x is equals to positive 7, so x here is equals to positive 7. That is now for this guy. All right, so you write positive 7 like that. Then for number 3, so what we do for number 3 is we are going to say chlorine there, then we are given with the oxygen with a negative there. So how do we do this one? So what we do is we say this one, let me bx this chromium, then x minus, so I'll say this is now it is plus that 3 oxygen is charged to negative 2. all right, then is equals to 1, which is given there on top. So you say x is minus 6 there, when you multiply is equals to negative 1, so x is equals to negative 1 plus 6, which is x is equals to what? Positive 5, like that. So this is the oxidation state of chlorine in this compound. All right, then question number 5 we are saying now we are calculating for what? For calcium there, open bracket nitrate. Okay, so what you do here, don't get confused if they mention a compound which is inside, just get from here and finish your stuff there. All right, so what you are going to do is you say you get that nitrogen. Let me just present the same n. All right, so once you do that, then you add. Okay, this 3 there is charged to what? Oxygen there we know is negative 2, its valence. So I'll say 3 open bracket negative 2. All right, is charged to what? This compound is charged to what? All right, how is it charged, this compound? Okay, so nitrate, the whole nitrate, now nitrate is charged to negative 1. So nitrate, it has a charge of what? Negative 1, like that. If you see, it's a radical, by the way, so you equate it to its charge. Okay, so that's how you do it inside when you're working inside there. All right, okay, so hope it is clear. Then you say negative 1, like that. So you say nitrogen minus 6 is equals to negative 5. So all right, so that is negative 1. So that is n is equal to what? Negative 1 plus 6, which will give us positive 5, like that. All right, so that was the answer in short for question 4. All right, so that is it. Let's go. Given the following reaction, okay, given the following reaction, identify the oxidation state agent. All right, and also reducing agent. So when you hear reducing agent, so is the agent or is a substance or a molecule that has been oxidized. So it's the one which is the reducing agent. So oxidize molecule, all right, or compound. Okay, so then oxidizing agent is the one which has been reduced. Okay, reduced molecule. All right, so it's more like the opposite. All right, so in this case we can get the two. So I'll get this, there are two half reactions that I'll get. Okay, so I'm concentrating on the major species. All right, so there are major species. I'll get this one which involve manganese to the same thing, manganese there. All right, and I want to compare how it has been reduced and also oxidized. All right, I don't concentrate on oxygen, I'm only concentrating on the main species. All right, so this main species here, we don't know here at this point. It had a negative 1. all right, here is 0, like that. Okay, so we are saying this is MnO 4 negative is equal to Mn. Okay, like that. So let me calculate the oxidation state of Mn here. So I'll say Mn, okay, plus oxygen there is negative 2, so I'll say negative 2 times 4 like that, okay, is equal to the charge given. So that is Mn now is equal to, right, so that is now negative 8 is equal to negative 1. So that will be Mn when you cross the other side, that will give you what, positive 7. All right, so this side it has positive 7. All right, so what about this side here? Let's calculate also. So we'll say Mn plus, there it is equated to 0, so oxygen is always having a negative, so I'll say negative 2 like that inside. Alright, is equal to the charge given there is 0, so I'll put 0 there. Then Mn there plus, that will be now negative 4, right, is equals to 0. So in short, Mn here is equal to positive 4. Alright, so this is positive 4. We can see that it has been what, reduced from the oxidation state, has been reduced from 7 to 4. That is the reduction. So that is the oxidizing agent. All right, so we can now see that chromium is an oxidized agent. Okay, so because it has been reduced, so this is equal to this guy. You get them from this place there in the first as reactant. All right, okay, like that. So then for the other guy we can see is the opposite, so this is the reducing agent. All right, because we can also see, let's prove it, let's prove whether it has been oxidized. All right, we'll see whether it has been oxidized. So how do we calculate now? We are saying chromium here, okay, so it's carbon. All right, it's carbon 2 there, oxygen 3 there, with a charge of negative 2 there, then 2 carbon 2 there, like that. Okay, so how do we calculate here? So we are here, it say we don't know, so we say x times this 2, you say 2x. Okay, all right, then here we know it's always having a negative, so that will be negative 3 times the charge of oxygen is negative what, 2, then it's equated to negative 2, like that. Okay, so this is negative 2x, then negative 6, like that. Yeah, this was plus, you add like that, so negative 6 like that is equal to negative 2. All right, so 2x is equal to negative 2 plus 6, which is 4. All right, 2x divided by 2. All right, x is equals to 2, like that. So this is 2 here, here it is having 2. What about this side? Okay, so here we are saying it has, we'll say x there on top, then plus the charge there is what, we'll say negative 2. All right, to, because it will be the, for oxygen is negative 2 there, the charge, so this time that is what is negative 4. All right, so you equate to the charge given, that in this case there was no number, so that's 0, so you're saying x is equals to 4. So we can see that from 2 to 4 of this thing, it has what, it has increased in the oxidation state. So we are saying now this guy has been what, reduced. Okay, so it is the opposite, don't get confused. So the reduced guy is now C2O3 negative 2, like that. All right, so these are the answer that you are supposed to write. So in short, the reducing agent is the agent that has been oxidized, and the oxidizing agent is the one which has been reduced. That's how you define these species. Okay, so we have identified those reaction, those species. Okay, so in case again if they ask you what is the oxidation state, or what is oxidizing state, so this is the increase in so for oxidation, okay, this one is the increase, it's just you only oxidize the state, the what's this, the oxidizing state, the state, then those numbers you are seeing as powers, once they increase, like that, let's say to 2 of that main species to 4 like that. So that is the oxidizing reaction. Then for reduction reaction, the situation by, let's say we have 4 here, and at the end there of that main species you find, let's say you just find, let's say 2 again, so meaning that it has been reduced. So that's a reduction reaction. That's how you do these things. They're a bit confused. You can find them in the lesson that we recorded. All right. Okay. So how do we do this one? We are done with this one. Okay. So write the two half reaction equation specifying which one is the oxidation half reaction and also reducing bus. But we are from calculating those, so there's no need. Let me we'll do them. Let's do them. All right. So we saw that this one, it is the oxidizing agent. All right. This one is the oxidizing agent, meaning that is the reduction reaction. Are we there? So this one is a reducing reagent, meaning that is the oxidizing reagent. So I would like to say this is now half for this one. It's now reduction reaction. Half reduction reaction, I'll say like that. So what I'll do is I'll write the same thing, Mn or 4, giving us Mn like that or 2 like that. All right, so this is the half reduction reaction. So we saw why it is half reduction reaction. So we are told to say write the two half reaction and specify which one is the half reaction, something like that. So we have written this is now the half reaction reduction. All right, so then the second one is what is, now we can just write it. We know that this is an redox reaction, so meaning there's the one which is reducing and the other one which is oxidizing. So now what we are going to do is we write the same thing. So we write the reactant, so O3 there, to negative, to what, to carbon dioxide, like that. Okay, so since you have written this, this is now what we call now, allow me to write like this, this is half oxidizing reaction. All right, I'm just writing like this. So this is it. Now the other question say balance each of the two half reactions. So I'll start with the first one. Here is how we balance these reactions. So I'll get the first one. So it's Mn, right, or 4 negative there, to Mn N or 2 like that. All right, so what we do is you calculate first, you balance test the main species. So we can see the main species having what, 1 1, so we are good like that. So what about just from here, then you go and balance the oxygen. All right, so here we can see we have 4 oxygen, there we have 2 oxygen. So I'll put 2 oxygen or H2O. So if I put H2O there, all right, have you seen H2O has what, has 1 oxygen, so it's making 3. So you put 2 H2Os so that you reach at 4. Here we have 2 plus this 2 there, that is 4. Here we have 4. So I've balanced the oxygen. Now by us balancing oxygen, we have made the problem of hydrogen. What the hydrogen now, there are 4 on this side, so we are going to put also hydrogen this side, 4 of them. So put 4 hydrogen like that, plus you put hydrogen ion to balance the hydrogen. So Mn like that, or 4 negative like that, then is equal to Mn or 2 like that, all right, plus 2H2O. All right, so that's how you do it. So you have balanced everything here for the first one. So what about for the second one? Okay, so for the second one, so we'll bring again the same thing, chromium, carbon there, oxygen there, with a negative there, then is equal to carbon dioxide like that. So we can see that there are how many, there you you balance now the what, the main species. Here it has 2, so I'll put 2 there. All right, it has balanced with the main species, but again I've affected the oxygen. Now have 4, all of them this side. Here I have 3. What should I do? All right, what should I do? I'll add the other one H2O molecule here this side, so that I can reach 4 as well. Okay, so what I'll do is I'll add H2O there, plus, okay, 2 oxygen, 3 negative, like that. Okay, they are now 4. We can see 3 plus 1, that's 4. Then we have 2 carbon there. Okay, they are now 4 4. All right, we have created the problem of hydrogen. You have put 2 hydrogen, so we'll add the other 2 hydrogen. All right, so put 2 hydrogen because there are 2 hydrogen, so I'll add 2 hydrogen and ion. You put ions, you can't just bring hydrogen itself. So like this, you have balanced the half reactions. All right, so allow me to lab here. We have already seen this. Okay, so that is it. So we have balanced the 2 half reactions. All right, so balance the 2 half reactions. So we have gotten this one. Then consider the reaction is taking place in basic media. Write the overall reaction. So for us to write the basic the reaction in basic media or medium, we will write first the what, the reaction in acidic. All right, so that's what we do. So what we are going to do is we bring the everything here. All right, everything excuse me. So what we do is you bring everything now. Okay, since this presence of hydrogen, so let me just bring everything. All right, so I'll say, please don't disturb here, please don't disturb. I'll put it here. Shaking. Don't try, please. Don't shake. I'll put this phone. I'll put everything. Just leave. Okay, just leave them. I'll put them. Okay, so what we are going to do here is we are going now to balance everything. We bring everything. So for chromium here, I'll bring this reaction. So I'll say magnesium there. No, I'll just bring the way it is there, the way it is written. All right, so I'll say so I'll like to say, I'll start from there. By the way, I'll get that reaction. So I'll say 4 hydrogen ion plus this compound magnesium chloride, so oxygen, like that, plus, okay, I'm done with these main species. I'm going for these main species, which are this point. All right, so I'll say H2O, all right, plus all right, so equal to, I'll get also for these guys. All right, so I'll say that is the, so those are the product side. Okay, so the product side now I'm getting magnesium, all right, manganese, then oxygen, like that, then plus H2O, like that. All right, then plus these ones now. Okay, so you add, it's more like we're adding. All right, to hydrogen ion, like that. Okay, so that is it. Then from here now we can see now things that will be cancelling. Here we have 2 H2O, here we have what, before I even do that, I'm supposed to do one thing here. Okay, I'm supposed to do one thing here. I need to balance the number of electrons. Okay, so the number of electrons at this point and also in this reaction, okay, they should balance. There I had 4, here I had 2 electrons for hydrogen, so we need also to at least do something with the hydrogen. All right, so what I'm going to do is what I'm going to do is, first, before I even do that, what we are going to do is we need to balance the number of electrons. How do we balance the number of electrons? All right, I really made that big mistake. The balancing of electrons should be done here. All right, here on, if you can see these charges here, all right, here we have positive 4 there, then here negative, all right, 1, so that will give us 3 electrons. But this point here we have 0, we have nothing this side, they are all zeros, so put 3 electrons there. All right, is that okay, guys? Is that okay? So electrons, so here we have 4 as 3 as a factor number, positive, because there was negative there. Let me just repeat this. All right, let me just repeat this. Okay, so if I do this, this is 3, then 3 minus that is 1. All right, then here I have, or let me just repeat this. Okay, I've left one important step of which you guys should follow. All right, so what you are saying now is, after you have just balanced these two guys, so you say for this one, for the first, so I'll say for the first one I have 4 hydrogen, positive hydrogen ion there, MnO4 to MnO2 plus H2O. All right, so for this reaction, what I'll do is, I can see there was a negative, by the way, here. I can see that this one, there's 4 there and negative 1, which will give me what, 3. So here I have 3 electrons extra. Here I have only this and this, they are having 0 as charges, so here I'm having 0. So what I'll do, electrons are negatively charged, so I'll add 3 electrons there. So 3 electrons plus 4 hydrogen, all right, plus 4 hydrogen ion there to balance just the electrons. All right, 4 like that, then 2 magnesium there, manganese 2 there, plus H2, or like that. Okay, that is for reaction 1. Okay, so for reaction 2, so this is reaction 1. Okay, for reaction 2 now, what I'll do is, here I can see there is only negative 2 like that. Okay, there is only negative 2. Okay, so what I'll do is, there are how many electrons there? There are 6. Here there are just 2, right? So what I'm going to do is, I need to balance this number of electrons. So how do I balance the number of electrons? So I'll say there are 4 extra electrons. So this side I have negative 2, right? But this side I have 2. All right, so they are not adding up. Okay, so what I'm going to do is, I'll say just to balance, since here I have negative 2, here I have positive 2, so I'll add another 2 electrons this side. So I'll say hydrogen H2O there, plus 2 oxygen 3 negative like that, then 2 carbon dioxide like that. Okay, so from here now I can see that side I have 2, all right, negative 2. This side I have what? Just positive 2. How do I balance? I need to have negative 2, so I'll add 4 electrons. All right, so these 4 electrons, when you add 2 plus 4, they'll give us negative, because they are negatively charged, more like negative 4 here, plus 2, which will give us negative 2. All right, so forget about this now. All right, so now what we do is, this is the balanced electron reaction. So what you do is you multiply now this number like opposite. So for this one you multiply times 4 number of electrons. For this one which is down you multiply times 3, because that's the number of electron we had here. Then also this is the number of electron we had there. All right, so that will give us what? So I'll multiply 1 now. All right, so this one is being multiplied by 4. Okay, this one by 3. All right, so this one is being multiplied by 3, because this 3 that we have there. All right, so here when you multiply times 4, that will be now 12 electrons. All right, plus 16 hydrogen ion. All right, plus 4 manganese, like that, then plus Mn, like that. There's 4 there. Okay, all right, so there's 4 manganese there, like that. Okay, then plus this will be now 8 H2O. All right, then for the second one we are now multiplying times 3 throughout by 3, so that will be 3 H2O, right, plus 3 carbon, like that. That will be now 6, like that. Then that will be, now you multiply it, that will be now 6 hydrogen ion. All right, then plus 12 electrons. So we just wanted to balance these 12 electrons. Okay, so what you can see now, these guys, when you add them, it can be a long thing. So what you are going to do, just cancel them from here. So we have this side here, like you add overall like that. All right, you add overall like that, so that this one goes and this one goes. Have you seen? Then in terms of number of water molecules, so let me just light a quick. In terms of number of water molecules, all right, so in terms of number of water molecules, what you are going to do is, in terms of number of water molecules, we are going to say here we have 3 water molecules on the left. On the right we have what? 8, all of them. All right, so we have 5 on the right because they are more than on the left, so that's what will remain with. So then the number of hydrogen, here we have 6, here we have 16, so we'll remain with the 10 on the right. So I'll start with this number of hydrogen. So 6 minus 16, here minus this one, so that will give me what? 10 number of hydrogen. So 10 hydrogen ion. Okay, plus I'm bringing this guy now. I'm bringing this guy. For electrons we are done, so I'll say 4 magnesium, like that. Okay, then negative there. Then I bring this guy now, this guy, so I'll put plus 3 carbon 2 oxide, like that, then equal to, so I'm now putting, now I've remained with what? Let me light again, 4 magnesium, like that. All right, then plus 6 chromium, like that, then plus the number of what? They are now done. Number of we are done with the number of water. All right, so this is the final ones. So this is now in acidic, all right, media. So if it is in acidic media, meaning that the number of it shows the presence of number hydroxide or hydrogen hydronium ion or hydrogen ion. So what you do is now in basic, all right, now in basic, what do you do in basic? All right, let me just lab. Hope you have copied. Okay, so now in basic, what you do is you bring this, you add. So you say those 10 hydrogen ion, so you add how many? 10 as well hydroxide ion on the side, both sides. All right, so you light 10, so 10, then hydroxide like that. Okay, let me just like that, let me just like to differentiate that 0 and the hydroxide. Then plus, now you bring the same thing, plus, right, then 4 like that, that is 2 by the way, then plus 6 like that. So you add also this side the number of hydroxide that you have just added that side. All right, hydroxide ion, you put that charge ion. All right, so now from here what you are going to do is this one they are adding, now they are making what? 10 H2O. All right, then plus 4, you just repeat the same. All right, plus 3 chromium like that, 3, okay, so plus 4 Mn like that, O 2 plus, so remain with what? So 6 carbon dioxide plus 10 hydroxide like that with the negative there. So this we have remained with hydroxide charge, so meaning that this media is now in basic. All right, so this is how you end, it's in basic. But before that we have number of water molecules there, right? We have number of water molecules. Okay, there must be number of water molecules that we are supposed to cancel, so I've just left them out. So you are supposed to, this is H2O, right? There was another 10 H2O which has been made this side, so you can go and check that number of hydroxide. We had 5 H2O this side. All right, 5 H2O. All right, so meaning that those 5 H2O, they will cancel now, they will cancel. All right, they will cancel this one with the 10 that you have just formed there. All right, so therefore the best answer, just that I've labbed, the final answer would be this side would have 5, because that's the number of water molecule would have remained with. All right, then plus 4 MnO4 plus 3 chromium like that, like that, then that is 4. So we have left some water molecules there. All right, so that's why we have just remained hanging like that without completing it. So I've left some water molecule, so you can just go check in the video, you'll be able to see. All right, so that will remain with what? This side with the 10 hydroxide. All right, so this is the answer that you are supposed to write in basic media. Okay, the presence of this hydrogen, you're able to see it shows that it's in basic. All right, which is alkali. So that is it. We have balanced this reaction. Consider the reaction, we write the overall. So this is the overall reaction that we are supposed to write. All right. Another question. This is just a dilution question. All right. So it's just a dilution question. So what you are going to do is we are saying we use the formula dilution equation to say v1 m1 is equal to v1 m1 like that. So the first data we have 25 volume 25.0 centimeter cubed times we have what, the molarity of 0.05. I can just say molarity like that is equal to, or decimeter cube mole per decimeter, just the same. Then here I have the 20 volume. Okay, so these are v2 and the m2 like that. So what we do is centimeter cubed then times the m that we are looking for, m2, that's the final concentration. So what we do is we divide throughout. All right, 20.0 centimeter cubed. So the centimeter and centimeter goes like that. I didn't want to take in 2 liters because I know they will cancel at some point, which is just the same. So I'll say m2 is equal to, divide, you multiply 25 times 0.0 divided by 20. That will give you what? That will give you 0.06 decimeter mole per decimeter to say, or molarity, which is just 0.06 mole per decimeter cubed. All right, so I'll put a negative without pay. All right, so that is it. That's how you calculate this one. Yeah, let's go to the next page. So list the 3 properties of gases. So gases, one, I can say they have about 8 properties that are just easy, that are close to our thinking. So the first one, you can say you can compress these gases. Let's say in a balloon, you can burst the balloon, so are easily compressed. So are easily compressed. All right, so gases are easily compressed. So you the other one, you can say they fill any container shape, or they fill the shape of, they make the shape of the vessel. All right, so completely fill any vessel shape. Okay, they are pressed in. Okay, so whenever you press them, they will take that shape. You put them in a balloon, they will be round as well, so they take that shape. All right, so the third one you can say is they mix completely with any other gas. So they mix with the other gases. All right, so when you, let's say you bring something which is stinking, they'll, the gases, even the normal gas that you have, it will mix, so they will mix completely with other gases. That's the meaning. So the other thing that we can say is these guys, they will exert pressure on the surrounding. So the moment the way I'm talking right now, there's pressure which is being, the air particles are being disturbed the way they should be, so they exert pressure on their surroundings. So they exert pressure on their surrounding. All right, so now we are told to write down the mathematical expression, or just equation for the following laws. So Boyle's law states that the at a fixed temperature and pressure, at a fixed temperature, for a dry gas, or for a mass of a dry gas at a fixed temperature, or at a constant temperature, the volume of a gas is inversely proportional to its pressure. All right, so we are saying so now this will be at a constant temperature, pressure is inversely, all right, to volume, meaning that this is the constant. Then when you multiply that, is 1 there, which will give you now K is equals to P V 1 like that. So meaning that the constant will continue P 2 like that. So the equation now will be P 1 V1 is equal to V2 P2 if you want, or P2 V2, like that. So that is the meaning. Then the B1's Charles law is that at a constant pressure, all right, the temperature or the volume of a gas is direct proportion to its temperature. That's the meaning. That's how you can give or you can state these laws. You can write that down. For a fixed mass of a dry gas at a constant pressure, the volume of a gas is direct proportion to its temperature. That's Charles law. All right. So meaning that if I say the volume is direct proportion to what, to its what, to its temperature. All right. So to its temperature. Okay. Then times K there. All right. So I'll divide times T. All right, to find K. So K is equals to V1 over T1. Since temperature constant is constant, so I'll continue getting the same. All right, until like that. So that's how we make this expression. So meaning that for B now, we can say that the formula that we can say V1 over T1 is equal to, again, V2 over T2, like that. All right. So that is it. That is it for this question. You can go to the next question. The question says, what is in volume in liters? What is, in short, it was supposed to be what is volume in liters of nitrogen required to react with the 18.6 grams of magnesium at a pressure of 1.20 atm and temperature of 3. So this is nice. So here you just needed to know the gas law, okay? So which state that I mastered to say VIP or just VP is equals to nRT, like that. Master, repeat after me. VP is equal to nRT, like that. Narrate. Vice President, narrate. All right, that's the meaning. So what you do is you are looking for what volume. So you do it like nRT over pressure, like that, where this one is the number of moles. The gas constant is 0.0862606. Then this one is also temperature given. The pressure is also given. So what next? Let's calculate. Let's just find the number of moles. All right. So number of moles we know is equals to mass over molar mass. All right. Forget about the English there. Just concentrate on the values and the data given. So the mass given there is 18.6. All right. So the mass of magnesium is what? 24, something like 24 if I'm not mistaken. So it's 24.31. okay. So when you calculate the number of moles, it will give you 0.765, like that, moles. All right. So these moles are the one that will replace there. So we'll put 0.765. all right, number of moles. Then the units will cancel, by forget about the units. In this case, they will still give you the liters if you were to follow the units. You can do it on your own. I'll just punch direct without replacing the units. Okay, so the universal gas constant that I'll use is 0.08. I was supposed to use, I'll put, given in the question, it was given in the paper, this one. So you can also put 0.6 there. Okay, 82.06. So then times the temperature given is now always in Kelvin. All right. So if it was given in Celsius, take it to Kelvin. All right. So over the pressure is now 1.20. So the volume now is what? When you divide that will give you what? That will give you 5.27, like that, liters. This is volume and liter. This is a standard for measuring volume. All right. So that is it about this one. That's how you are supposed to calculate this one. So define partial pressure. So when we say partial pressure, all right, when we say partial pressure, so partial pressure is just the pressure exerted by an individual gas in a mixture of those gases. So if I have gas A, gas Y plus gas Z, all right, so these guys, the pressure that they have, those values that they have to exit outside, they say the vessel, so we have Y, Z plus X, like that. So this one, for the pressure that it exits on the container, is what we call its partial pressure. All right. So all these, that's the partial pressure meaning. So the question now, consider a mixture. So we are saying, should I write that? Okay, so I'll say partial pressure is the pressure exerted by an individual gas. So pressure exerted by an individual gas in a mixture of those gases. All right, it is called partial pressure. Okay, that is it. So we are now consider a mixture of two gases, A and B. All right, confined or put in a closed vessels. A quantity of third gas, so they have put gas C again, is added. So we had the vessels of A and B like that filled inside. Then we bring another C there. Have you seen? So there will be that disturb or that fight. So it's added to the same temperature at the same temperature. State whether of the following will increase, decrease, or remain the same. So since they are in the one vessel, then we have brought they had already another pressure. Then what will happen when you bring another pressure? So this partial pressure again, or just another pressure of C, or when we put it, the partial pressure of gas A will increase, right? Because no, the partial pressure of in short, the value, it is still having the justice. Let's say it has just small like a kahook, it is still stick to this. Even if that guy comes, it won't be stable. So not change, this one will not change. All right, because it is just still the partial pressure. Let's say it had 2.0, all right, atm, that's its partial pressure. So that can't be changed. All right, so the total partial pressure now will change. So this will change, we even increase. All right, we increase because we have added and we have still a small vessel, so they will be interacting frequently there inside. Then for more of fraction gas B, this the more will do what, will reduce, because let's say we had for B we had 3 atm, then the total, let's say it's 9. All right, so bringing the other 3 there, let's say to give us 12. So meaning that the value will reduce. This will be 0 point something, then here it will be 0 point something when you divide by 9, which we had in the first place. So meaning that it will reduce because we are increasing the over the total number, which is dividing. So even for gas A, the more fraction will reduce as well. All right, or will decrease, to say, by the English used in the vocabulary used in the question. All right, so that is it. So a mixture of gases containing 4.5 moles of neon, 0.74 mole of argon, 2.4 moles of what? This element. So now what you are going to do is, you know what? So calculate the partial pressure of gases. So each gas, so to find the partial pressure of a gas, you say partial pressure of that gas is equal to individual pressure. All right, so what you do is individual gas pressure. So I'll say that gas pressure times the total. All right, total. Okay, so that's how you'll be finding the partial pressure of X. Okay, so now given that these are the moles, so find the ratios of moles now in these vessels. So they are all of that. There's 0.74, there's 2.5. all right, there's also 4.76, like that. So we'll find the each now. So what I'll do is I'll say each now partial pressure that is there, just partial mole. We are getting partial moles now. So this is partial mole times the total. The total is always given. All right, so the total is 2 there. So I'm saying partial pressure of a gas is equal to the partial of, let's say these are grams or moles or whatever values that they'll give you, then times the total. That is the partial pressure of that gas. So what we are going to do here, we are given the moles, so get the moles partial pressure. So I'll start with the neon. Okay, partial pressure of neon is equal to let me calculate now the partial pressure, the partial mole. So partial mole of neon is equal to that value of neon, which is just 4 point, all right, which is 4.76, okay, 4.6 is 4.76 over the total. Now you add all these guys, so we have 0.74 plus 2.5 plus 4.76, like that. You add the total, then that will give you what? 0. When you divide 595, like that. Okay, so that is the individual mole pressure. So you say that 0.595 times the total pressure now that they have given you in the question, always, that is 2. So you report your answer in 2. So I'll say this is, now when you divide that, you multiply that, that will give you 1.19 atm. All right, so the partial pressure of argon, so the partial pressure of argon, I'll say, let me find the partial mole of argon. So partial mole of argon, so I'll put the value of argon there on top. That will be what? 0.74, all right, over the total now, 0.74 plus 2.5 plus 4.76, like that. So that will give me what? That will give me 0.093, like that. So you bring now to say 0.093 times the total pressure that they give you in the question. So that will give you what? That will give you 0.093. okay, so this is atm always. So that is it. Then for partial pressure of this gas now, which is just Xe, xenon. So same Xe is equals to the value of xenon, which is 2.5 over the total, all right, 0.74 plus 2.5 plus 4.76, like that. So when you divide, that will give you what? That will give you 0.312, like that. All right, so that is the individual mole pressure or partial. So say of xenon, like that, is equals to, you bring that value 0.312 times 2, which will give you what? 0.624 atm, like that. All right, so that is the partial pressure. This is how you calculate. You'll be given a series, or let's say in masses or in grams, in moles. So you put the partial pressure of those in terms of the partial ratios, all right, then you multiply the total pressure given in the question. That's how you do it. All right, okay, so that is it about this one. That's how you are supposed to calculate this one. Okay, so now the next question that we are supposed to calculate is the an unknown gas diffused at a rate of 0.5 time that of nitrogen at the same temperature and pressure. Calculate the molar mass. So this is the diffusion rate. So what we do is, you always write like this. The formula is the rate of that gas unknown, all right, that unknown, you divide with the rate of the difference, all right. So in this case is the nitrogen given, all right, then is equal to root of, all right, molar mass of the same, so they should match those differences. So molar mass of nitrogen, all right, over molar mass of unknown, all right, let's say x. Okay, so the rate, now you bring that number they have said the times. So in this case is 0.5, all right, is equal to, all right, you do this. So forget about this, you just put that rate that they give you, all right, then you put the molar mass of nitrogen now here, which is 28 grams per mole, right, then over the one you don't have. So we are calculating the molar mass, all right, by the way. So they are all under the root, so you cancel the root by multiplying with 2 there, so that will give you 0.25 is equal to 28 over x. So you cross multiply there, so that will be 0.25 x is equals to 28, like that. So meaning that you divide throughout by 25, like that, 0.25. So that will be x is equals to, when you divide that 0.25, when you divide that, you are going to have 112 grams per mole. All right, so this is the answer. This is how you are supposed to calculate. So this is the molar mass of the gases and unknown. All right, so that is it. So know the equation to say that time they give you, all right, rate is equal to that loot, all right, that reference material that they have given you over the unknown. So that master this formula, please. All right, master it. So this marks the end of our lesson or our paper. I've tried to answer it in 1 hour 15 minutes. So that is it. So thank you for watching the video. Hope you are writing these down, and make sure that you follow all the lessons that we post. Join us for online lessons, and you'll be able, the best way is to go through past papers. I encourage everyone, especially those guys who are repeating courses, do just past papers. The exam is standard. Even for the papers that we answered already, there are papers that we answered. So if you can access those papers, meaning that you can do what, you can have fast revision and effective revision. All right, so that is it for this. We are done. All right, thank you very much for watching the video. See you in the next video, where I'll be doing all the papers. So all the papers videos are available, a lot of videos are available. Make sure that you subscribe. All right, thank you very much.